My passions were about the human body, so how it works and why. So I decided to inscribe myself at the biomedical engineering at the University of Aix-Marseille. The goal of my research is to understand the changes related to osteoporosis and try to develop diagnostic tools that increase the diagnosis of this problem. Osteoporosis is very well known and it affects many people. Just for giving some numbers, 1 in 3 women and 1 in 5 men aged 50 years will experience a fragility fracture due to osteoporosis. Osteoporosis is currently diagnosed by X-ray analysis, which has some limitation. Among those, it has only the 70% of accuracy, which means that 1 of 3 people are misdiagnosed. What we think is that we could use also the bone microstructure and the bone inner morphology to provide some more information to the clinicians. I work in 2 labs. One is in Château-Gombert, where we acquire cadaveric femurs using industrial microtomography, which is able to provide us with the real microarchitecture of the inner bone morphology. But it's a technique that is not applicable on humans, on in vivo patients, because it's a very radiation exposure. In Latimone, instead, we perform MRI images. We were able to investigate the bone inner structure and microarchitecture. We assessed many different features, like the bone volume fraction, the trabecular thickness, spacing, the orientation of these trabeculae, and many others. Ici, c'est l'os original. Nous, on se focalise sur la partie centrale, donc sur cette partie ici, dans la tête du fémur. Et donc, c'est ici, voilà. Vous voyez bien que les trabécules sont bien orientés avec une direction principale. Et donc, on a vu qu'il y a une direction préférentielle à 60-70 degrés et une orientation secondaire perpendiculaire au premier. Et ce que nous, on a pensé, c'était de voir si la distribution de cette orientation, c'est toujours pareil dans les os sains et dans les os malades. Et ce qu'on a vu, c'était que cette gaussienne ici, c'est plus petit pour les os malades. Et donc, ça veut dire que les patients ostéoporotiques, ils ont des orientations que c'est plus petit. Et donc, ils sont plus fragiles. Then I do biomechanical test, fracture test at Sainte Marguerite Dromel, and also spectroscopic analysis. The combination of this approach would allow us to create a new predictive model based only on MRI image analysis that could be applied on in vivo patients. I like a lot what I'm doing now, so I would like this to be my future, the academic and the research. So I hope to find a postdoc and continue on doing what I like.